This is the video for 3.8 and we're talking about unions and intersections of sets. I am going to deviate slightly from the book in this section. If you have not taken the time to read the first 2 pages of these notes, please do so. Pause the video and read those if you have not read the first 2 pages. Okay, so let's go over the first example here. So the first example is what's known as a conjunction. It's an and compound inequality. And so what I want you to do is I want you to hit pause and go ahead and solve this just like we've been doing on the homework. Okay, so once you solve it, you need to break it up. You need to solve the first part and then you need to solve the second part. Solve them individually and then combine it at the end. So if you did not get that as your answer, then you need to pause the video and redo it. Okay, so let's think about what a compound inequality is. By definition, a compound inequality is 2 sets of numbers. Now, sometimes those sets of numbers intersect and sometimes they don't. So let's look at this compound inequality. We have 2 sets of numbers. We have all real numbers that are greater than or equal to 3, and we have all real numbers that are less than 6. And so what is the solution here? The solution is the set of numbers that they have in common. So I graphed both. And look at what happens here when I graph both, just so you can understand what's happening here. So right here, I have one set of numbers, all real numbers that are greater than or equal to 3. And then I have another set of numbers, all real numbers that are less than 6. And so then what is the solution? The solution is the intersection. It's the numbers that they have in common. It's the overlap. And so my solution is going to be all real numbers that are greater than or equal to 3 and that are less than 6. And so how do I communicate this? How do I communicate this as an intersection? This right here is the symbol for intersection. If you look on the mathematical symbols handout that I gave you a few days ago, you'll see that there. The solution or the solution or the intersection contains the elements that both sets have in common. I have 2 sets of numbers, and I'm saying that the solution is the intersection. It's the elements or the numbers that both sets have in common. Okay, so now let's go to the next one. So here's the next one. The absolute value of 4x minus 6 is greater than 14. And so what I want you to do is I want you to pause the video and I want you to solve that again, just like we've been doing on our homework. Okay, so once you do so, again, you should know to break it up. Solve each side individually. Be careful when you break it up. Watch what you're doing there. Greater than 14, less than negative 14. And so you solve them both individually and you have an or statement. And so when I graph it, I have a disjunction. They have no elements in common. And so what's the answer? This is what we call a union, and this symbol communicates a union. You have 2 sets of numbers, x is greater than 5, and you also have x is less than negative 2. You have 2 sets of numbers. And so the solution is the union of these 2 sets. In an inequality joined by the word or, the solution is the combination of the 2 individual solutions. So I asked you to read these 2 pages here, but I just want to go over this first paragraph with you. When 2 inequalities are joined by the word "and," the solution of the compound inequality occurs when both inequalities are true at the same time. It is the overlap, so the solution is going to be the overlap or the intersection of the solutions for each inequality. So in other words, when you have a compound inequality joined by the word "and," the solution is going to be that set of numbers that they both have in common. But when the 2 inequalities are joined by the word "or," the solution of the compound inequality occurs when either of the inequalities is true, either or. It's either going to be greater than this or less than this. The solution then is the combination or the union of the 2 individual solutions. So back to our examples that we were doing, this is a union. The top one was an intersection, and this is a union. So really mathematically what we're doing is nothing different than what we've been doing over the last few days. The only thing that's different is how we are communicating our answer. We need to communicate our answer as either a union or an intersection of sets. And an "and" statement is always going to be an intersection, and an "or" statement is always going to be a union. Okay, so go ahead and hit pause and work out the 2 on your own problems that I gave you. When you work this first one out, you find that this is an it's a intersection. This is an intersection of 2 sets. And the next one is a union of 2 sets. And notice I did that on purpose. If you notice, the problems are the exact same. All I did was flip the sign so I can show you the difference between a union and an intersection of sets. Okay, so go ahead and do your homework and email me if you have any questions.